All right, today we're diving into a concept that's a real game changer for both artificial intelligence and our data privacy. It's called federated learning, and it's completely reshaping how we think about training AI. Let's get right into it.
So it all really comes down to this one kind of mind-bending question. How can an AI possibly learn from our most private, most sensitive data, things like our medical records or our personal text messages, without ever actually seeing it? It sounds like a paradox, right? But that's the exact problem federated learning was born to solve. So here's our plan for today. We're going to start with what I call the AI privacy dilemma. Then we'll get into how learning without sharing is even possible. We'll see how it all works in action, look at some real-world uses, touch on the big challenges, and then we'll wrap up by looking at what's coming next.
Okay, so let's kick things off with a fundamental conflict that really set the stage for federated learning. It's this constant tug-of-war between AI's insatiable hunger for data and our, very human need for privacy.
I mean, think about it. If you want to train an AI to be amazing at spotting cancer in medical scans, you need a ton of examples, and not just from one hospital, but from hospitals all over the world. But trying to gather all that sensitive patient data in one place, that's a privacy nightmare. This is the classic dilemma that has really held back progress in some incredibly important fields, especially healthcare.
And this is exactly where the solution comes in. It's a totally different way of thinking, a new paradigm for how we do machine learning. Federated learning basically flips the traditional script on its head. It's a method where tons of different devices, think our smartphones or computers in a hospital, all work together to train one shared AI model. And here's the absolutely crucial part. They do all of this without their raw, private data ever leaving the device. The only thing that gets shared are the mathematical lessons learned, not the data itself.
This really shows you that core shift. In the old centralized way, all of our data had to travel to one central server where the AI model lived. Federated learning does the exact opposite. The model itself travels out to all the devices. It learns on your device using your private data, and then only a tiny anonymous summary of what it learned gets sent back. Put simply, the model comes to the data doesn't come to the model.
Now, this comes in two main flavors. First, you have horizontal FL. This is where everyone has the same type of data, but just different examples of it. The perfect example is your phone's keyboard prediction. We all type different messages, but it's all the same basic data structure. Then you have vertical FL, and this is where it gets really interesting. This is when different companies have different kinds of information about the same people. Imagine a bank and a retail company teaming up. The bank knows your finances, the retailer knows your shopping habits. They can collaborate to build a better model without ever having to share their sensitive, specific customer data with each other.
So that's the what, but how does this all work under the hood? Well, it's basically a four-step dance that just keeps repeating itself. It's really this elegant loop. Step 1. A central server sends out the current version of the AI model to a bunch of devices. Step 2. Each device takes that model and trains it a little bit using its own local private data. Step 3. The devices send back only the updates, just the new knowledge, not the data. And finally, Step 4. The server takes all those little updates, averages them together, and creates a new, smarter global model. And then the whole cycle just starts all over again, getting better and better with each round.
Now, this isn't just some theory stuck in a research lab. Let's take a look at where federated learning is already being used out in the real world.
And the impact is already huge. You've got hospitals that cannot work together to train diagnostic AI without ever compromising patient privacy. Autonomous vehicle data from different cars can be combined to make self-driving models safer for everyone. Banks can team up to build way better fraud detection systems. And of course, the example you probably use every single day, your phone's keyboard getting smarter and predicting the next word you're going to type, all without your private texts ever leaving your device.
But, as amazing as all this sounds, federated learning isn't some kind of magic bullet. It definitely comes with its own unique and pretty significant set of challenges and security risks.
The problems really fall into two big buckets. On one hand, you have the training challenges. All those updates being sent back and forth can create a lot of network traffic, plus you're trying to coordinate across tons of different devices. Some are fast, some are slow, some have great data, some have spotty data. On the other hand, you've got the security challenges, because even though you aren't sharing the raw data, the system can still be vulnerable to clever attacks from bad actors trying to poison the model or even figure out someone's private information.
Yeah, it's a real cat-and-mouse game between attackers and defenders. You've got threats like data poisoning, where an attacker tries to corrupt the model by feeding it bad data, or model poisoning, where they send a malicious update directly. There are even these really sneaky backdoor attacks where the goal is to make the model fail on one very specific, targeted task. But for every attack, researchers are hard at work developing defenses, like systems that can automatically spot and reject a suspicious update, or using advanced privacy techniques to make it harder to reverse engineer anything. But despite all those challenges, the field is just moving at a breakneck pace. So what does the future have in store for federated learning?
One of the most exciting innovations on the horizon is something called one-shot learning. Remember that communication bottleneck we just talked about? Well, this is a potential solution. Researchers are trying to figure out ways to learn the global model in just a single round of communication, which would slash the network traffic and make the whole process way more efficient.
And then, things get even more futuristic. People are seriously looking at integrating federated learning with blockchain technology. Why? To get rid of that central server entirely. Instead of trusting one single company to aggregate all the updates, you could use a secure, transparent blockchain as a decentralized ledger. It would create a truly trustless learning network with no single point of failure.
And the research is pushing even further. Two other huge areas are, one, designing incentive systems. How do you get people to volunteer their device's computing power? Maybe you reward them for it. And two, developing what's called asynchronous learning. This would allow devices to check in and send updates on their own schedule, making the whole system much more flexible and resilient for real-world chaos.
And all of this incredible work, all these innovations, they're all pushing towards answering one massive, holy grail kind of question. Is it even possible to build a federated learning system that is completely attack-proof, that guarantees perfect user privacy, and is efficient and cheap to run? That is the ultimate goal, the grand challenge, and trying to solve it is what makes this one of the most exciting and important frontiers in all of artificial intelligence.